So the task we have at hand is to develop a function that will accept an input parameter of a picture, go through all of the pixels in the picture, and reduce the red value of each pixel. So let's think about what we need to do. Well, first of all, since we're going to be working with media, with an image, we need to include the from import statement so we have access to those modules. So from JustForPy import asterisk. Again, that gives us access to the extra set of library functions that allow us to easily manipulate images and sound. And then if we're developing a function, we need a definition statement. So def, and then we need a function name. So let's call this reduceRed. And then we need parentheses and a colon. But since we're going to provide input to the function, we need a parameter here. And since the parameter is going to be a picture, let's use a descriptive name, picture. So now we're ready to actually start writing some code. Well, as I describe it, we're going to accept this picture in, and we need to process through all of the pixels. That sounds like a good place for a for loop. We can use what I call a for thing loop, where we go through all of the pixels in the picture, and each time through the loop we can access one pixel. So remember, the for statement is a for something in something type structure. So for something in something, and then we need a colon at the end. Better spell for correct. So where are we going to get, in this case, the pixels from? Well, the pixels are part of the picture. And we have a function called getPixels that we can use to get all of the pixels. So let's make use of that. GetPixels, and the pixels are in picture, so I'm going to put the variable picture. And then we need to fill in that first blank for something in getPixels of picture. And since each time through this loop we're going to get one pixel, let's call it pixel. So we have for pixel in getPixels, parenthesis picture, parenthesis colon. That's set up the loop. Each time through the loop it'll give us one new pixel. And when the loop finishes, we will have had access to all of the pixels. So what do we need to do inside the loop? What do we need to do to every pixel? Well, our goal is to access each pixel and reduce the amount of its red value. So let's get the current red value of this pixel. You may recall we have a getRed function, and we need to give it a pixel. So we'll put our variable pixel there, and it's going to give us back a value. So let's call this variable red value and assign it what we get back from getRed. So the statement we have then is red value equal getRed parenthesis pixel parenthesis. Now we have the value of the red component of the pixel. What do we need to do to it? Well, we need to reduce the value of that, and in this case let's reduce it by half, so it'll be half as intense in the red component. So we'll take red value and multiply it by 0.5. And I notice I misspelled red, so let's fix that. And we need to do something with that then. We've got a command that's sort of the opposite of getRed. There's a setRed function. So let's say setRed, open parenthesis, and we come here at the end and close it. But setRed actually needs two parameters. It needs to know what pixel we want to set the value of, and then the value that we're setting. So let's insert pixel here. So we have set red parenthesis pixel comma red value times 0.5 parenthesis. So notice we're doing some math here as an argument, as a value we're giving to the function. That's totally fine. We can do arithmetic within what we're passing. It just has to evaluate after it's done that calculation. It has to evaluate to a number that would be between 0 and 255, the range of possible values for the red component. So let's take a quick look. We've imported our functions so that we have access to these functions like getPixels and getRed and setRed. We've defined a function, giving it an input parameter of a picture. We've created a for loop where we're going to go through the loop and retrieve from the collection of all pixels, one pixel at a time, placing it into a variable called pixel. We're getting the red value of the pixel, setting that to a variable, and then in our next statement we're using that value that we get, multiplying it by 0.5, reducing it by half, and using that to set the red component of the pixel. So let's load and run our program. Everything seems to have loaded okay, so we've probably typed it correctly. Let's create a picture that we can give our function. So I've typed picture equal make picture, and inside the parentheses for make picture I'm going to put pick a file. I'm pressing enter. That opened the window off camera, so I've drug it in. Let me maneuver to the folder that contains the picture I want to use. Let's use the arch picture. So I've told it I want to use the arch picture. It has read that in, processed all the bits via the make picture, and placed all of that processed data about the pixels of the picture into the variable called picture. I can now type reduce red and give it the input of my picture variable and press enter. It's done its thing. It's given me the prompt back, but didn't show us the picture, and that's appropriate. There's nothing in our function that tells it to display anything, but it hopefully has gone through and made the changes. And so let's show our picture at this point. That opened it up off screen. So here is our current version of it. Now what I should have done before running this is display the original so you can see what it looked like. So let's do I'm going to up arrow a couple times and get the picture equal line again. I'm going to reselect the picture and show that version. So again, it opened it off screen. Here is the original, and here is our changed version. So we'll drag these over so we can see the code and the pictures. We have the original on the left, the new on the right. We've reduced the amount of red in the picture, and so it's taken on a more substantially greenish, grayish tint to it. Just because of the way red interacts and makes other colors, those other colors have changed as well. Green is a little bit greener than what it was. The red isn't quite as bright. It's a little duller, darker red than the original. And what was originally a sort of a beige, khaki type color has taken on a definite green hue to it. Black is still substantially black. White is still substantially white. So, with very few lines of code, we've altered the appearance of this picture. See if you can write some similar functions that you can dream up. We'll see you in class.